So, here we are going to talk about natural ordering. All built-in types have what is called a natural ordering. So, this natural ordering is actually a numeric ascending ordering. Objects have a natural ordering if they come from a class that implements the comparable interface. This natural ordering is specified by the overridden compare-to method. So let's see, we have class arrays. Class java.util.arrays is a utility class that contains various methods for manipulating the arrays. These methods can be sorting or searching methods. There are a number of sort methods for sorting arrays of built-in types. So, if you want to sort an array of objects that are using the natural ordering, you just can use the method void sort, and then as the input parameter you can pass in that array of objects. And you need to keep in mind that your object type must implement comparable. So that's the case that your array of objects are using natural ordering. What if your array of objects use some other custom orderings that are not natural ordering? Then how can you sort these objects? In this case, you can use the method void sort, and then as the input parameters you can pass in the object and comparator. So here object is that array of objects, and comparable is an interface that you need to implement. You also need to override the method int compare to specify your ordering rule. So you can do that with a regular class or with an in-year class or an anonymous in-year class. To make these notions more clear for you, I'm going to give some more examples so that everything be clarified for you. Well, in this example, I'm going to show you how we can have an array and how we can sort the array. So this example is going to use the compare to interface, and we are going to use a regular class, not in-year class. So we have a public class sorting, right? Let's first define an array name array. So this array is going to have several elements like Bob, for example, Fred, Billy Joe, Jennifer, John. So that's the array that we have. Then inside the main method, we have public static void main string args So here we are going to import java.util.star, right? So we can use the methods inside this package. So now what we are going first is we want to print the original unsorted array. So system dot out dot println, and here print rule and array original name list. So print rule and array is a method that we are going to define. So this method static is going to be static void because it's not going to return anything, and then print its name is print rule and array. So what this method is going to do is it's going to receive, for example, a string. It's going to print that string, right? That string is called, for example, rule. And then we are going to print the elements of the array unsorted. So we are going to implement that with a for loop. So here, first we are going to print. So what it's going to receive as an input parameter is string, rule, and system. So that's the rule. For example, here, original name list, and then we are going to print this rule. So system.out.println, and then we are going to print the rule. And after that, we are going to print the elements of the array in an unsorted, that is unsorted. Yeah, right? So we implement that with a for loop. So for int I equals 0, as long as I is less than the length of the array. So the array that we have here is name array, right? This one. So name array dot length, and we are going to increase I by 1 each time. And then we are going to print the elements of this array. So system.out.println, and then name array I, right? So by this for loop, we are actually printing the elements of our array. And at the end, we are going to print system.out.println and a space, right? So let's see. So now let's see how we can see the result and what is the output by running this code. So I'm going to run the code. So as you see here, I can see the elements of the array one by one and unsorted, right? Then I want to, in the next step, sort my array by natural ordering. So as I mentioned in the slides, when we have the array of objects that have natural orderings, then we can sort them by using the method sort, right? So easily, I will use the method sorts arrays dot sort, and here I'm going to sort the array. So arrays that sort, then what I'm going to pass as the input is the array, right? So name array. So now what I will have here after this line of code, my array would be sorted, right? So the order of the elements of this array will change. So then let's write print rule and array in order to see the name array, elements of name array, and see whether they are sorted or not. So what I'm going to pass as the rule here is sorted by natural ordering right? So let's run the code and see the result. So as you see, what we have in array is Bob, Fred, and Ralph, right? And here I have, after calling the sort method and sorting this array and then printing the elements, I will have Bob, Fred, and the third one would be Jennifer, right? Because this array is sorted, right? Okay, so in the next step, we are going to sort the array by length. So we will have, again, we need to call array.sort and then name array and new length compare, which is a class for comparing strings by length, right? That's a comparator. So what we will have for this class is, so class length compare implements compare, comparator, string, public, int, compare, string s1 and string s2. So it's going to get strings s1 and s2, and it's going to return s1 dot length minus s2 dot length, right? Then we are going to say print rule and array sorted list in by name length. Let's run the code and see what we will have as the result. So as you see, we were able to sort the elements of the array based on their length, right? In the next step, we are going to sort the elements of the array alphabetically, right? So we will have arrays dot sort and then name array and here we have, for example, the class, this object here is new alpha, for example, compare, right? So this one, that's a class that is going to compare strings alphabetically, right? So let's define this class here. So we have class alpha compare that implements the comparator string. So inside this class we have the method compare it receives two string S1 and string S2. And it's going to return S1 dot to lowercase dot compare to S2 dot to lowercase, right? So it will, for each string, it will first make them in a lowercase format, then it will compare the strings. And if these two strings be the same alphabetically, then it will return, for example, true, else false, right? So here we have this class that implements the comparator, and here we have the sort. We have sorted this array alphabetically. So the next step is printing the elements. So print rule and array sorted list in alphabetical order. Let's run the code. So as you see, we have sorted this array alphabetically, right? So first we have Billy Joe, then Bob, and so on. In the next step, we are going to sort the array lexicographically by last letter. So again, we call the sort arrays dot sort name array new, for example, last letter compare. So here what we have is we need to define the class last letter compare that implements comparator string and here we have a public int compare string s1 and string s2, and we are going to return s1 dot So we want to compare the strings by last letter, right? So S1 dot char at the last letter is S1 dot length minus 1 because it's the last letter, right? So now we have the last letter of S1 minus, we want to have the last letter of S2. So S2 dot char at S2 dot length minus 1. Right? So that's the comparator that we have here. By defining this comparator, we are actually sorting our array based on the last letter of each element. So let's see what is the result. I just forgot something here I need to print. Rule and array sorted list in lexicographic order of last letter. Let's run the code and see the result. Well, so now you see first, the first element that has been printed here is Joanna, since the last letter of this element is A. Then we have Wanda, the last letter of this one is A, right? We have Bob, because the last letter of this one is B. So that's a very simple example that shows you how you can sort the array by calling the method sort and defining different comparators. As you see, the first one, what it does is sort the arrays based on the length of the elements right here. Actually, the first one just sorts the array with natural ordering, right? In natural ordering. And then here, the next one, we define a comparator and pass an object into the sort as the second element. This comparator actually compared the length of two elements, right? So now this sort, what it does is sort the elements based on the length of them. In the next one, the comparator is different. It compares the elements alphabetically, right? So, as you see here, it will check them alphabetically if they are compare them actually. If they are alphabetically equals, then actually compare them compared to if whether they are alphabetically similar or not, and based on that it will sort the elements of the array alphabetically, right? So the first element would be the one that, as you see here, starts, for example, with the letter B lowercase, right? And finally, for the last comparator that we have here is it compares the last letter of the elements, right? So, as you see here, it will compare the last letters of the elements and will print the elements that are, for example, if the last letter is, for example, A, it would be printed first, right? As you see here in the example, for example, Joanna has been printed as a first element. So that's how we can use the sort method in order to sort the elements of arrays of objects. Let's see another example that in this example we are going to do the same task as the previous example, but we are going to implement the interface with static nested classes. So first, let's import java.util.star. So here we have the array the same as the previous one. So static string, that's an array of strings with the name array, right? So here we have Bob, we have Fred, we have Ralph, and so on. Then we have the main method, so public static void main string args. First, we are going to print the original unsorted array. Like the same as before, we are going to have the method print rule and array, right? That is going to print the elements of array one by one. So static void, since it's going to return, it won't return anything, but it will print something. So print, its name is print rule and array, and then string rule as the input. So we are going to print system.out dot println. First we are going to print the rule, and then we are going to print the elements one by one by implementing it with the for loop. So for int I equals 0, I less than, as long as I is less than the length of the array. What's our array name? Array.length. We are going to increase I by 1. And then we are going to print the elements. So name array I, right? And finally, we are going to print the space. Well, that's the method that we have for printing the elements of array. So the first step is printing the original unsorted array. So system.out.println space, and we are going to call the method print rule and array by passing the string original name list as the input parameter. Let's run the code. So let's run the code and see the result. So as you see, we have printed the elements of array one by one. And then in the next step, we are going to sort the elements by natural ordering. So you know how to do so. You can easily call the method sort arrays dot sort and then pass the array as the input. So the array here is name array, and then print these elements of the array, print rule and array, right? And here the rule is sorted by natural ordering. In a lexicographic order, right? So easily you can sort that, and then we are going to sort the array by length. So we are going to sort the elements by length. So that's a class that we need to define. So here we are going to use the nested class. Okay, so here what we are going to do is we are going to sort the array by length. So the same as the previous example. We have arrays dot sort name array and new length compare. So we need to define the class length compare by nested class, right? So inside our class sorting2, we are going to define this class. So private static class length compare is going to implement the comparator. So what this class is going to do is it's going to compare the length of strings. So we have a string s1 and a string s2. And what it's going to do, it's going to return s1 dot length minus s2 dot length. Right. Let's run the code. But before that, let's print same as before. So here is sorted list by name length, right? So as you see, this is the nested class. This class has been defined inside the sorting class, which is the main class, right? So let's run the code and see the results. So as you see, the array has been sorted based on the length of the elements. First, I have Bob, then Joe, and so on. So the length of the first one is 3, the length of the second one is 3, and the third one is 4, right? So let's sort the array by based on the alphabetically order, right? So sorting alphabetically. So we are going to call the method arrays.sort and then again name array new, and here we have alpha compare, right? And again we are going to print the elements. So I'm going to print sorted list by length. Sorted list in alphabetical order. Right. So now let's define the alpha compare class inside the class that we have here. So it's going to be a nested class. We have private, static class, and alpha compare is going to implement comparator string, right? So actually we are going to implement the comparator to compare strings alphabetically. So public int compare string s1 and string s2. So it is going to return s1 dot to lowercase dot compare to s2 dot to lowercase. Let's run the code and see the result. So as you see, the array has been sorted alphabetically, as you see here. In the next step, we are going to sort the array lexicographically by last letter. So, again, we are going to call arrays dot sort name array new. This class, the name of the class for that implements this comparator is last letter compare. Right. And then we are going to print the array by calling the method print rule and array. So the rule here is sorted list in lexicographical order. Right. Then for concatenating these two strings, we add plus of last letter. Well, so now let's implement the last letter compare class. So again, that's a nested class. So here we have private static class and the name of this class, which is last letter compare. That implements compare comparator string. Right. So we have public int compare string s1 and string s2. What this is going to do is it's going to return s1 dot char at s1 dot length minus 1 minus s2 dot char at s2 dot length minus 1. Right. So that's what we have here. So this comparator compares the last letters of the elements and sort the elements based on the last letter. So let's compile, let's run the code and see the result. So as you see, the sorted array is as follows, and the first element is Joanna. As you see, the last letter of this element is A. The last letter of the second one is A. The last letter of the third one is B, right? So you see it's being sorted based on the last letter. So this is the implementation of sorting the array by using the nested class. Okay, let's see the implementation of the same example by static nested classes. And in this example, we are going to use the comparator interface without generics, right? And as I mentioned, with static nested class, so we are going to implement the interface with the static nested class. In the previous one, what we did was we used the comparator interface by using the generics, and we implemented the interface with the static nested classes with names. Right. So let's see what we have in this example. So again, let's import java.util.star. Right. And here again, we are going to have static string name array. That's an array of strings, the same as the previous example. I have the public static void main as the main class, so string args, and here the first step is printing the arrays unsorted, so print rule and array. So here we have the original name list. Right, so again, the same as the previous one, we are going to define this method exactly the same as what we had in the previous example. So I will copy and paste this one. Right. And the next step would be sorting by natural ordering. So as you see, I have printed them, original one, and then I'm going to, again, the same as the previous one for natural ordering. So I will just copy and paste these parts because everything is the same as this one. Right. The only thing that is different is for defining the classes, for implementing the comparators. So here they are again static nested classes, so they would be defined inside the public class, right? So for the first one, which is the length compare, for comparing the length of the elements, this one, so instead of strings, we are going to pass the objects as the input. So object O1 and object O2, and here we need to take the length of the first object O1. So first we need to change the type to string. So string O1 and here a string O2. right? That's for the first one. For the, for example, comparing the elements alphabetically, we had this class to implement the comparator. So here we had public static class alpha compare implements comparator. For strings here, we need to omit this part because it's not a string anymore. It's going to be objects. So object O1 and object O2. And here, again, the same as what we had here, we have objects. So first we need to change them to string. Right. And for the last letter compare, again, that's the same. For implementing the comparator, so it's not a string anymore. It's objects, object O1 and objects O2. And here, we don't have S1 and S2 anymore. We have O1 and O2. So we need to, because we are using, for example, here char@, and char@ is just specific for strings. We need to change the type to strings. So a string O2, and here that's the same. A string O2, right? So as you see, we implemented the same example, used the comparator interface without generics, and we implemented the interface with static nested classes. Let's run the code and see the result. So you see, we can have the result exactly as it should be. So you saw two previous examples. The first one, we used the comparator interface using generics, and we used the nested classes. For the second one, we used the comparator interface without generics, right? And we used the nested classes as well. In this example, we are going to use the comparator interface using generics along with anonymous in your classes. So again, let's import java.util.star. So here, that's exactly the same as the previous one. For the string, so static string name array is going to be the same as the previous one, what we have here. And then we need to have the main method. So public static void main string args. First, we will print the original unsorted array like what we had in the previous examples. So I just will copy these these 4 lines of code because they are the same, right? Then, and also the method for printing and then we are going to sort them by length. So arrays dot sort name array so that's an in-year class, right? So new here what we have is because we are going to use the comparator interface using the generics, right? So comparator new comparator string, right? And we are going to define the class here. So it's public int compare string s1 and string s2, right? And we are going to return s1 dot, so the difference between the length of s1 and s2. Right? So you see what it means by having the anonymous in-year class. It doesn't have any special name, right? And we are directly defining the class here instead of defining the class separately and then creating the object and passing that object as the input parameter to the sort method. We are directly defining this class here without those names that we had, for example, private, static, and what we had here for the length for like the previous examples we had length compare, right? Its name was length compare, but we don't need it here anymore. And then we are going to print the elements of the array. So sorted by name length. In the next part, we are going to sort them alphabetically, right? So arrays dot sort name array as the first input, and as the second input new comparator string. So here again we are going to define this class directly. So public int compare a string s1 and a string s2. And what it's going to do, it's going to return s1 dot to the same as before, s1 dot to lowercase dot compare to s2 dot to lowercase, right? So here again we were able to implement the comparator, actually this class alpha compare directly right inside parentheses and without giving a name to this class. So for the last letter compare, that's the same. So I will just copy these lines of code, and here I will have, so here instead of, I will have arrays that sort. The first one is name array, and the second one is an object right. we need this one as well, so I just copy these lines of code. So here I'm going to paste this method.